divisors. I will assume like you have never seen them before, even though I suspect that you have. Or at least most of you. Good? Is that all 7 here? Okay. Alright, so greatest common divisor, got our largest integer that divides both of these guys. Because of that, we cannot talk about our GCD of 0 in itself. Not that we usually would want to, but because any integer besides 0 divides 0. So there is no largest integer that divides 0. So we're going to do some examples that do make sense. So our first one is going to be our GCD of 36 and 54. So what's our greatest common divisor? 6 is a common divisor. 9 is a common divisor. 18. So one way we can do this, if it starts getting complicated, is we can do our prime factorization for both of these guys. And in this case, they have the same primes, just how many times they're repeated is different. And so both of them have 2 common to both. So we go by the lower exponent, which is a 1. So there's a 2 to the first common to both. And then same thing, they both have a factor of 3 in common. Well, how many? Go by the lower exponent. That's 2. And that gives us our 18. So that's one way we can always do this. Questions on that? So the next one is easier, but what's our GCD here? 11, right? So 33, of course, is 3 times 11. Not that we need to do this for this particular example. And 121 is 11 squared. 3 isn't common to both of them, so we don't use it. 11 is common to both, so we use the lower exponent, which is to the first power. So next one, we've got GCD of 81 and 64. What's our greatest common divisor then?
9.
Does 9 divide 64? How do you factor 64?
8 times 8.
Alright, 2 cubed times 2 cubed. What about 81?
9 squared.
primes and common. You want it to be something larger than 1 because 81 and 64 are beautiful, perfect squares with lots of factors, but they're nothing in common. So these guys we're going to later have a definition for, because they have no factors in common, we're going to say that these guys are an example of integers that are relatively prime. And it's the same as saying that their GCD is 1. All right. And so if we take the GCD of 1 and 12, what do we get? And so 1 and something else will always be this relatively prime. So, cheating without having the definition yet. I'll make it review later. All right. Questions so far? What about the GCD of 0 and 12? 12, right? All of our positive integers divide 12. So we just look at the highest, or I think I said it wrong again. I said it wrong last time too. All of our positive integers divide 0. So since 12 divides 12 and it's the largest positive integer that divides it, it still works over here, so it's common. So the GCD of 0 in any positive integer will be that positive integer. Question? All right. One more. This one comes factored, so we can work with larger numbers. It works off that same principle we had before. So we've got 2 cubed times 3 to the 7 times 5 to the 4th. And then we've got 2 times 5 to the 7 times 7 cubed. What's our GCD? 2 times 5 to the 4. Yeah, so again, we look for what's in common to both. They both have factors of 2. Common to both, there's only 1. This guy's got factors of 3, but this one doesn't, so we don't care. They both have factors of 5. Common to both, lower exponent, which is the 4. This guy's got factors of 7, but we don't care because there aren't any here. And so, questions on this?
It's just the one with a 0, the 12. So basically, if there's a 0 in any part of it, you can always just, forget about it because it doesn't matter? Or?
Well, it's because every positive integer divides 0. So, so 12 divides 0 in particular, since 12 times 0 is equal to 0. Remember, that's our definition of divides. So all of our positive integers divide 0. So yes, whenever you have 0 something else, it's got to be the something else for this reason, that we can always do this. And that's also the reason that we don't want 0 to be the other one there. Is because then there's no limit. There's no greatest common divisor.
Okay, I understand.
Other questions? So on Monday, corrected exam questions. I know a bunch of you have already done these. Gives you a little extra chance to look it over if you have any doubts. Separate sheet of paper attached to your exam. Also, there will be a quiz. 3 definitions. The remainder mod's the hardest one because it really means you need to know the division algorithm. Congruence mod, and what it means for A to divide B. So these are your definitions. It's a 3-question quiz that we'll write probably on Monday afternoon. But in any event, you know what's on it.